So we've got another differentiation question. The gradient dy by dx of the curve C at the point xy is given by this thing here. For 2 marks, part A, show that y is increasing. Y is increasing. You mean it's going up. You mean dy by dx. If things are going up, dy by dx must be bigger than 0. Show that that is true when that is less than 0. Okay, so what have we got? Dy by dx, which is this thing, is bigger than 0. We've got to get from there to there. What can we do? Let's put it in the right order first of all. Negative 6x squared plus 20x take away 16 is bigger than 0. What have we got to do next? I can see things being halved. Negative 3x plus 3x squared plus 10x take away 8 is bigger than 0. But we got less than 0. But everything's been multiplied by minus 1. So 3x squared take away 10x plus 8. What do you do to the symbol when you multiply or divide by minus 1? You've got to flip it. That gets us to the line that we need. Okay, part B, solve the inequality. So this time we've got an inequality. We're thinking, what does it look like? This is a standard quadratics question now, just sort of put in with a differentiation question. I wish it would factorize. Okay, let's have a look. We're going to need a 3x and we're going to need an x. What do we need? Could it be 8 and 1? Probably not, because we've got a 3. Could it be, I reckon, a 4 and a 2? What if we put a 2 here and a 4 here? We need a minus 10. They both need to be negative then. So does that work? 4 minus 4x minus 6x. Yeah, minus 4 and minus 6 gives me minus 10. Just be careful there. Do that check to make sure that it does come out the right way round. It's easy to get these confused and you lose a lot of marks when you don't need to. Okay, so when is that equal to 0? There are critical values. Okay, that's going to be equal to 0 either when x is equal to 2 or when 3x is equal to 4, or in other words, x is equal to 4 over 3. Okay, so when is this thing, when we solve this equation, when is it less than 0? Well, I can see because it's a positive x squared coefficient. Here comes our diagram. Positive x squared coefficient, that it's happy curve. It is happy curve. We know that we've just worked out that it crosses the x value, the x-axis. What's that? 4/3. That's 1 1/3. Okay, so that must be the 4/3. That must be the 2. We want less than 0. So we want this bit in here. Give it a tick. We want that bit. So we need x to be between, not equal to, but actually between 4/3 and 2. Okay, at this point, let's just check the mark scheme before we go any further. Mark scheme says, there's our thing, correct interpretation of y increasing. So actually, it's a bit cheeky. It's like the question sort of reversed itself. Understanding that increasing means dy by dx is bigger than 0. Sticking that thing equal to 0, it gets us 1 mark. Multiply by minus 1 first and flip the sign, and then factorize afterwards. Must see at least one of these steps. So basically there's 2 steps. Multiply by minus 1 and factorize by 2, or divide by 2 essentially. Okay, correct solution only. Got to get to the answer given. No errors in the working, so no mistakes. We're at question 7 now, aren't we? So they're being quite strict about that. Okay, with our quadratic, correct factors, or you could use quadratic formula, getting as far as this. 1 mark for the correct factors. 2nd mark for saying the critical values, 4/3 and 2. We're allowed to have equivalent fractions, but not in the final line. They do like to see a sketch of a diagram. You get a mark for that, so make sure you do that. It's good to sort of indicate which bit you want as well. Final answer, 1 mark for the final answer, whether you've got it that way around or that way around. You're even allowed it as 2 separate ones, but not an or. It's got to be and, not an or. Okay, here's an important bit. Mark their final line as their answer. So don't then go and put something afterwards and lose out. easy marks. B part 1. The curve passes through the point 2, 3. That's our x value. That's our y value. Verify that the tangent to the curve is parallel to the x-axis. Okay, so here's our x-axis. If it's going to be parallel to the x-axis, then gradient must be 0 because it's flat. So we're looking for dy by dx to be 0. Okay, when we put 2 into it, because it's all x values, so x equals 2 implies that dy by dx is going to be equal to 20 times 2 take away 6 times 2 squared take away 16. What does that give us? That's 40 take away, mind your BIDMAS, 4 times 6, which is 24, take away 16. 40 take away 24 take away 16 does in fact make 0. Let's give it a statement. Tangent parallel to x-axis. Okay, just a nice conclusion statement there. Looking at the mark scheme there, x equals 2, dy by dx equals, look at that, nice and straightforward. 40, 24, 16, we've substituted it in and we simplified the term, and look at that, must be all correct plus statement. So we've got to have that statement just to conclude. Okay, so before we go any further, I'll just give you your question to make sure that this is your evidence that you've watched the video. This time, could you write down for me, or bring in or tell me, write down the equation of the circle that has a centre 1, 1 and a radius 3. Equation of the circle with centre 1, 1 and radius 3. Okay, we've just done part 1 where we said that the tangent is parallel to the x-axis. That was parallel to the x-axis when y equals 3. So actually, the equation of that tangent, it was parallel to the x-axis, as in no x's, and we had a y value of 3. Okay, so that was just the equation of that tangent is y equals 3. Okay, this point, the point Q also lies on the curve. The normal to the curve at Q and the tangent to the curve at P, this thing here, intersect at the point R. Find the coordinates of R. Okay, before we find the normal, let's get the equation of the tangent, or the gradient of the tangent, because then we can work out, from there we can work out the gradient of the normal. Okay, we've got an x value of 3. Okay, sticking that into our dy by dx. X equals 3 implies that dy by dx equals 20 times 3 take away 6 times 3 squared take away 16. 20 times 3 is 60, take away BIDMAS. 6 times 9, which is 54, take away 16. 60 take away 54 is 6, take away 16 gives us minus 10. Okay, so the gradient of the tangent equals minus 10. So the gradient of the normal is going to be using our m1, m2 equals minus 1. Gradient of the normal is going to be 1/10, positive 1/10. Okay, so thinking about the equation of our tangent, the equation of our normal now, y equals mx plus c becomes minus 1 equals 3 over 10 plus c. I can see straight away that c would have to be, we've got to take away 3/10 and 10 more tenths. C is minus 1/10. So we can write now the equation of our normal is y equals x over 10 take away, it's 13 tenths there, isn't it? Take away 13 tenths. Okay, and we're saying that that intersects with that line up there. So actually this thing is equal to 3. Oh, this looks nice, doesn't it? Because now we've got something we can actually solve and find out a value for x. Timesing everything by 10. X minus 13 equals, times it by 10, 30. So then x is going to be equal to 30 plus 13, which is 43. The coordinates of R x is 43, y we've already said is 3. 7 marks. Let's see what got those marks. B part 1. Verifying that the tangent at P is parallel to the x-axis. X equals 2 gave us 40. Take away, we've already talked about that. The last bit, x is equal to 3, gave us a gradient at that point of minus 10. We attempted to sub x equals 3 into dy by dx to get the gradient of the tangent. So therefore the gradient of the normal is negative reciprocal minus 1 over your 10, gives us our 10th. Normal attempted with correct coordinates, okay, used and the gradient obtained from their dy by dx value. Okay, so now it's going to get the equation of that normal, which we had any correct form. I think we had something like this. We actually had it divided by 10. But we did simplify the negatives. Equation of tangent at P is y equals 3. Solving that then gave us our x equals 43. Okay, 1 mark for subbing x equals 3 into the differential. 1 mark for working out is minus 10. 3rd mark for negative reciprocal. 4th mark for attempting to get the equation of the normal. 5th mark for getting the equation of the normal, any correct form. 6th mark for y equals 3. 7th mark for x equals 43. Looks a bit nasty, but not actually as bad as we expected. Hope it's useful. Thank you very much.